I'm Jack.
I'm Zach.
And our unit is waves.
And in our unit, we'll be covering mediums, mechanical waves, period and frequency, wavelength, amplitude, constructive and destructive interference, superposition, deflection, standing waves, and sound-specific waves.
So our first topic for waves are mediums. A medium is basically the substance through which a wave travels. Basically, a medium, all that is it's just something that takes the wave and allows it to transport its energy through it to get to another place. So an example of that would be like in the ocean. Like the ocean waves, the water is the medium. The energy is being transported through the water and moving it to another location. Those are like the waves that are being formed. So an important thing to note about that though is that electromagnetic waves do not require a medium. They don't need a substance to transfer their energy through to move. That's only mechanical waves. They're the only waves that are affected by a medium. Now, an example of an electromagnetic wave would be like an X-ray. Like you don't need anything for that energy to go through, unlike a mechanical wave. With sound, for example, the air is the medium and the sound travels through it. And in a vacuum, there's no air, sound can't travel through it. So that's all the most important things that you need to know about a medium.
Our next topic is period and frequency. Period refers to the time it takes to do something. The period of a wave is the time for a particle on a medium to make one complete vibrational cycle. In other words, it's just the time it takes for a wave to complete one full cycle. So you have your wavelengths right here. It's just from the start of the wave to the end, the time. But frequency, on the other hand, refers to how often the particles of the medium vibrate when a wave passes through the medium. That basically means like when the number of waves that basically means the number of waves that pass through the medium in a given amount of time, or in other words, the period. They're reciprocals of each other and can be found with these equations.
So our next topic for waves is going to be wavelength and amplitude. Now wavelength is basically the distance from crest to crest or trough to trough of the wave. The crest is the highest point of displacement on the wave or on the medium to the next highest displacement, or the lowest displacement to the next lowest displacement. That would be the wavelength. And that's basically just the length of one cycle of the wave on the medium. The next is amplitude, which is the maximum amount of displacement of a particle on the median from its rest position. Which you can see this dotted line, this would be the rest position, that would be the max displacement on the top side, and this would be the max displacement on the bottom side, and that's basically just the height of the wave. Next topic in waves is constructive interference. Constructive interference is basically when two crests or troughs coincide and they join together. This basically means it's just two waves. They have to be in phase with each other, so it's basically two of the same wave, and it results in them combining to make an even bigger wave. Now this results in a wave in which the amplitude is the sum of the two waves' individual amplitude, so they combine together to make a wave that's twice the original size. As you can see in the picture, this is the first wave and this is the second wave. They're in phase with each other, the same wave, and they join to create a wave that has the amplitude of each of these, which basically is just two of these. So the height of the waves is twice each of these. So to follow up on the last topic, we also have another type of interference called destructive interference, and that's basically when a trough and a crest coincide and the peaks of one wave line up with the valleys of the other, and the waves are said to be out of phase. And that basically just means that the waves are meeting together and their mediums are like joining and causing a new shape to be made. So as you can see, the crest right here is meeting with the trough right here, and the trough is meeting with the crest, and the trough is meeting with the crest, and that's just resulting in a medium that has a new shape to it. So our next topic for waves is superposition. The principle of superposition can be applied to waves whenever two or more waves travel through the same medium at the same exact time. the waves pass each other without being disturbed, and the net displacement of the medium at any point in time is simply the sum of the individual wave displacements. This is true of waves which are finite in length or which are continuous sine waves. Now, as you can see in the picture, two waves are colliding, they're coming together, they each have their own individual displacements. They meet in the middle, and their two displacements add together to make a net displacement. And then after that, the waves are still going and they just go their separate ways undisturbed.
Reflection is simply when waves bounce off objects or surfaces. An example would be the reflection of light or the reflection of sound or water waves. Here we have an image of just a ray reflecting off a barrier at the same angle it hit.
So our next topic is the specifics of sound waves. So we'll begin with resonance. Now, resonance is basically when one object is vibrating at the same frequency of a second object, which causes that second object to vibrate, and it physically vibrates and makes a loud sound. Then you have loudness. All loudness is basically just the amplitude of a wave. So the smaller the amplitude is of the sound wave, is the quieter the sound is. If it has a larger amplitude, then it's going to be a louder sound. Next, we have the Doppler effect. Now, the Doppler effect is produced by a moving source of waves in which there's an upward shift in frequency for the people whom the source is approaching. Now, there's a downward shift for the people whom the source is receding from. And as you can see in this picture, this is a car right here going to the right. Now, it's leaving this person, so there's long wavelengths and a low frequency. So this person is going to hear the car at a lower pitch. Now, the car is approaching that person to the right, so it's going to be, the waves are going to have a small wavelength and a high frequency and a high pitch, so they're going to hear it at a high noise. So as the car approaches and passes you, it makes the meow sound. Next, we have beats. Now, beats are the periodic and repeating fluctuations heard in the intensity of a sound when two waves of similar frequencies interfere with each other. Now, previously we described constructive and destructive interference, and this has to do with beats. When constructive interference occurs between two crests or two troughs, it makes a loud sound. But when you have destructive interference and you have that between a crest and a trough, it makes no sound at all.
Different types of mechanical waves. So first we have transverse waves, and they're just oscillations where particles are displaced perpendicular to the wave direction. So it'd be as if you had a slinky and you're going up and down with it, as you can see here with our drawing. And then our next wave is longitudinal waves, and that's basically just waves that are parallel to the wave direction. That's how they're displaced, like if you're pushing slinky outwards, which one? Like you can see in this image. And an example of longitudinal waves would be a sound wave. They travel through the air, which is its medium, and we previously talked about mediums. And they can exist in closed and open loops as long as there is at least one node. So as long as there's one node, they can exist, but if there's less than one node, they cannot exist. The topic is standing waves and waves on a string. Here you can see with this experiment is a sine wave generator creating standing waves. Standing waves are waves which appear to be vibrating vertically without traveling horizontally. They're created from waves with identical frequencies and amplitudes that interfere with one another while traveling in opposite directions. So as you can see here, we have our sine wave generator that generates the wave. You can turn the amplitude down and the wave is smaller, or up to make the wave bigger, and the frequency just creates more wavelengths. As you can see, it creates more wavelengths. And it can go all the way up to the point where the waves are basically non-seeable. Thank you for watching our crash course video on waves.